Good morning, good morning, good morning. Hi, Janae. Hi, Olivia. Hi, Claire. Hi, Nicholas. Good morning, Vanessa. Good morning, Abril, Jackson, Alexander, Mark, Jordan, Thomas. I know some of you are working on that homework late. I hope you managed to get it done and feel like you learned something. And I know you have some questions. And I'm going to take those questions. Good morning, Kiana. And before I do, I'm just going to point out a few things. All right, so I'm going into the lesson 1 folder first. Parsa, good morning. Okay, so while I'm showing what I want to show, I'd like to know, those of you who have been messaging me from within the OHM assignment, are you receiving my messages back to you into your Palm Beach State email inbox? So you can answer that in the chat, and I'll see that in just a moment. I'm just wondering if you're in the OHM assignment and you're clicking on the email my instructor, if it actually, when I respond, do you get it back in your email, your Palm Beach State email? Vanessa says no. I didn't see anything, says Kiana. Okay. All right, so I'm in lesson 1, and I'm going to go to where it says lesson 1 videos. And there's 3 videos that I made yesterday in response to questions I was receiving, and I put it in an announcement in Blackboard. So you should be receiving these into your Palm Beach State email inbox. Whenever I post new information, it'll go there. So it's a good idea to be in the habit of checking your email, because useful information comes through periodically. And so one of the things I did was to let you know about those videos. And there's a few shooting issues I'll have today, working on figuring out why the gradebook isn't syncing, because it's supposed to. So we'll be working all those kinks out, just so you know. But let's go back to lessons, test 1 learning module, lesson 1 videos. Okay, so those 3 videos. I kept getting this question 15, so I'm going to go over one of those again today in this session. And there's that recorded one. This is a student and I met in the course room, and we went over it. And then these other 2, just from what I was receiving from students, it seemed like maybe the content that was available wasn't sufficient. And so I'm talking about the chapter 12 lesson. And the more you guys touch base with me, the more I know, since this is the first time. And I can watch a video and think the students are going to be great with that. It's very well explained. But until you guys do it and share with me how it, what your experience is, I can't know for sure. So keep up the good work for those of you who have been communicating with me regularly, and we'll get it done. So I'm going to go into the guided learning assignment for lesson 1. Click to launch. Start a 2-week trial if you haven't already been in there. All right, so at this point, the assignment is being counted late. That's a 10% deduction. So you can still get 90% when your homework is late. And it's only going to deduct 10% off of the questions that you are working on after the due date, not the entire assignment. All right, so the first question that I kept getting was this one, and it's a scatter plot. These are several different scatter plots. That means that you have pairs of x comma y data, and Kiana asked if when you submit the homework in OHM, do I automatically receive them? Yes, I have all your grades. It's just that they're not communicating with the Blackboard gradebook for some reason. But don't worry, your progress is being saved. And if I have to, I'll end up inputting the grades by hand.
I had a quick question about the homework also.
Sure, go ahead, Ariana.
Just really quick, for there was no button to really submit. It was just like when you're done with the question, you're done with the questions. Does that automatically like submit to you, or is there a button we're supposed to like
Uh,
complete?
I believe that every time you complete a question, it saves your progress.
Okay, thank you.
Yes. My Wi-Fi wasn't working. Okay, glad you made it. So this right here, I'm tempted to go through the whole lesson again, but I did record it from scratch. This whole lesson about linear regression, because what it is you have paired data and they make points that you can plot on a graph, x comma y. And when you plot them on a graph, you want to see if there's some pattern there. And specifically, we're looking for a linear one. And each of these has a linear pattern, but some of them are stronger than others. And some of them look like the points are increasing when you read it from left to right. And some of them look like they're decreasing when you read from left to right. So if you can recall the equation y equals mx plus b, see if you know, first of all, are you familiar or do you remember, I'll type it in here, y equals mx plus b. And if you do you remember what the m stands for that's attached to the x and what the b stands for? Yes, the slope, actually guys. And the slope is the steepness, right? Like if you're walking uphill, how big are your steps? How high up do you go as you go forward? And the b is the y-intercept. That's right, Claire. So when you're looking at these problems, they're asking you to identify linear strength, which has a sign on it just like the slope would. The slope of a line that would go through dots to fit it, the slope of that line would be positive because it's increasing from left to right. So the correlation coefficient, which measures the strength of the linear relationship, will also be positive for this one right here. And the next one is slightly trending upward. This one, the third one here, is trending downward. So that would have a negative slope and a negative correlation coefficient, R. This one looks like some of the data would pull it upward and some of it would pull it downward, so you'd end up somewhere in the middle. So that's probably got a slope somewhere close to 0. Because when you try to fit a line to it, there's confusion there about which way to go. So it kind of pulls against each end and you end up somewhere in the middle. So now we've talked about the sign, and I think most of you figured that part out. But what about the actual number value on these? Well, the R relation coefficient, it measures the strength, or like another way to put it is how tight and clear the dots create a line pattern. So if they're tighter, then you get a correlation coefficient that's stronger. And if they're looser, you get one that's weaker. Now, strong means it's far away from zero. It doesn't have to be positive. It could be strong, moving upward like this, or it could be strong like this one right here. It's got the strongest correlation. It's got very strong negative correlation compared with the others. This one's got a weak correlation. You see how loose the dots are there? So here are my choices, and I'm going to match them up. So for the first one, I'm looking for a positive, and that would be B, C, or D. I don't think it's going to be B. I don't think it's that weak. Maybe it could be D, but the second one here has a positive correlation that looks weaker. So I would choose C for this one because it looks like probably the strength is around 0.6. That seems about right to me. The next one, I would choose D because it's got the weaker correlation there. Then this one here is the only one that's negative in my choices, so that made it easy. But also notice that it's very close to -1 at 0.9, so that's a strong correlation. So that would be A. And this one here, which looks loosey-goosey, would be the smallest absolute value. Remember, absolute value means the distance from zero. So this has the smallest distance from zero, and so I'm going to check that one. That was, what was that? B. Okay, and then when you get it right, you see the check mark, and so you're done with that question. You can do a similar question if you want to keep trying them, and you can message your instructor if you need to know more. And then I can do demonstrations like I'm doing today. So the only reason I knew the problem needed me to go over it because students told me so. I didn't think this problem was going to be difficult based on when I watched the video that I assigned for the lecture. I didn't think that this was going to be a thing. So it's definitely important for you to communicate with me. All right, the correlation coefficient R is a number between -1 and +1. Let's go on from there. Also, real quick, guys, when I'm in like this, can you see the questions well enough on your view? Yeah, okay, good. I'm not seeing everybody's responses. Okay, cool. Good, thank you for chiming in. Okay, so this one says, if the correlation coefficient is negative, this means, that means that it has, let's see, there is a strong correlation between variables. No, that's not really what it means. The regression line can be used. No, there is no correlation. No, the calculation was wrong. The test statistic T cannot be calculated. No, it's just that the slope of the line would be negative. Okay. And then submit question. I already did. Okay, gotcha. So now we'll go on. In order to indicate a strong correlation between variables, the correlation coefficient will be strong correlation. Remember, we'll have the greatest distance away from zero, and it'll be between 0 and 1. So that would mean it would be near -1 or +1, because either one of those would be a greater distance away from zero. To test the significance of the correlation coefficient, we use the t-distribution with how many degrees of freedom? Okay, now I know you probably don't know what the t-distribution is yet, You don't need to. There's a chart in your lesson 1 vocabulary and formulas insert, or I guess it's an insert in the book, but it's a PDF in your lesson 1 file. So right here where it says lesson 1 and it's kind of cut off there. But if you check that out, it's called the lesson 1 and lesson O vocabulary and formulas. So when you scroll through here, you're going to find definitions. You're going to find information about how to use Excel and other important tips, notation, things like that. So if I go down here, continue all the way to the bottom, there is the critical values of the sample correlation coefficient table. Right? And once again, if what I'm doing seems piecemeal, I put a new video that just is very structured so that you can watch that lesson. And it's not too long. So now it said in the book and in the lectures, we use n minus 2 degrees of freedom, and it also says it right there in the table. And what we're looking at here is a place that you can look up a number to compare your correlation coefficient to. So the one that comes from the data is called your test statistic, and the one that comes from this table is called your critical value, because it's the value that's critical. It's the value that you have to beat. It's kind of like a goalpost. And so you want your value to be stronger than whatever you get out of this table. Right? So the answer to this one is n minus 2 degrees of freedom. Okay, here are the scatter plots for two sets of bivariate data with the same response variable. The first compares the x and y, the second compares the variables w and y. Which explanatory variable has a stronger relationship with the response variable? So just looking at this, which one looks stronger to you? That's okay, Abril, I understand. The second one, yeah, WY, exactly. Very good, very good. The tighter fit to a line pattern is what makes that stronger. Now, also notice that I noticed that a few students were not seeing these videos that are linked in here. So sometimes if you watch that video, it'll clear it up for you. And other times you might need to let me know that I need to make a better video, because these videos were already attached to these questions. And, you know, I might be able to do better. So just let me know if that happens. I need to know. All right, so we're going to go on to another one here. Choose the most likely correlation value for the scatter plot. Okay, can you guys please tell me what you think the answer should be?
R equals 100.
Oh, hi. Yeah. This 1.1, right? The weakest one, the one that has the smallest distance from 0. Okay. Right. So I'm happy to see how much you guys are understanding. I see you guys are chiming in here. And, you know, by the way, it is after 8:15. So if you are good to go with lesson 1 and you're ready to go work on lesson 2, you're free to go and enjoy your homework. You can come back if you need me. But if you want to stick around, I'll keep doing more problems from the homework. So let's go on to another one. All right, what about this one? What looks like the best type the number right into the chat. .995. Wait for a couple more answers. .995. Uh-huh. Okay, you guys are all in agreement so far, it looks like. Okay, very good. Oh, why did I click that? I clicked that. All right, next, let's see. This one. What do you think the answer is? Negative. Okay, good, Mark. You're putting that negative on there. Very good. Okay. How can you tell, Vanessa? Are you asking about this problem right here? Haley guesses negative 0.5. Claire says negative 0.89. Okay. So, the answer, it's pretty tight, right, Haley? Good. So I was going to say, I'm glad you said that. So, yep, it looks very, very strong. Like I can see a very clear line there. You know, they're never perfect, but it's very good. So it should have a large distance away from zero, and it's trending downward, so it should be negative. So remember, you read these things from left to right. Just like I read a sentence from left to right, I read graphs from left to right too. That's decreasing, so it should have negative slope and negative correlation coefficient. They're not the same thing. I should say that. Slope and linear correlation are connected. Actually, the slope is used as part of the, it's involved in the calculation of R in certain forms of the formula, but they're not the same. They do share the same sign, but they're not the same. The slope tells you how steep it is, but this tells you how tight the dots are. And so there you go. There's that answer. I guess I can move on. Sometimes I talk too much about something, and sometimes I don't talk enough about other things. So keep me now. A correlation of R equals 0.85 is found between weekly sales of firewood and cough drops over a 1-year period. Which of the following is true? All right, so R equals 0.85. That's pretty strong. I kind of see anything over 0.7, I'm calling that strong, or at least moderately strong. So there is a pretty strong positive linear relationship. That looks like the right one, but let's always read the others just to see if there's anything that could be a better answer. There's this one that says both A and C are true. That looks suspicious to me. What does C say? Temperature is a possible lurking variable that is behind this relationship. Okay, so we have a lurking variable, maybe. So if the sales of firewood are increasing at the same time that the sales of cough drops are increasing, is it just because the firewood sales of firewood, people buying more firewood will cause more cough drop sales? In one way, I could say, yeah, if they're sitting around bonfires and then they're inhaling smoke, they might end up having a raw throat and need cough drops. But is there another reason that they could be connected? Yeah, because firewood sales happen more when the weather gets colder. People get sick more when the weather gets colder. So I would say both A and C must be true. Right, the temperature, Claire. Okay, so now we'll get into the meat of having to do things technologically. You have to do some calculations now. And I signed a video where I showed you how to do all this. It was the EMP, the Excel mini project that you could follow along with. And I showed you how to use the formula of the correlation coefficient. I'm going to open up my little PowerPoint here to refer to a couple things as I'm talking. So I'm going to demo this in Excel. But what I wanted to say is that you don't have to do the calculations using the formula during the test. I want you to try it because it'll help you learn Excel and it'll give you some experience with what that R value is instead of just having this weird number that gets spit out of a calculation. But you don't have to do that for me during the test. It's too many steps. So what I'm talking about is this formula right here. You don't have to do that. Okay. You don't have to show me all the steps to calculate that. But you can use Correl for if all you want is the linear correlation coefficient, you can just use this. Or if you need to have the regression equation too, or you need to see the trend line too, then you can do these steps. You can insert a scatter plot, right-click the points and select Add Trend Line. Check the boxes to display R squared and the regression equation. Take the square root of the R value to get R. Now, when you do it this way, you have to pay attention to the sign because it won't give you the right sign if it's negative. And then you compare here, if you're trying to tell if the linear strength is strong enough, we use this table, right? So let's do this step by step here. All right, so we'll go ahead and select the data, copy it, and then paste it. All right, now let me read that question again so I know I'm answering the right thing. It says down here, yes, significant correlation or no. All right, and there's a video here, but we're doing our own right now. So at the 0.05 significance level, does the data show significant linear correlation between X and Y? Okay, so the significance mention here is something that we can assume when we're using this table. It's built around a significance level of 0.05. You're going to learn more about significance levels later in the term. It has to do with the probability of us being right. Or it's kind of the probability of us being wrong. 0.05 is the maximum probability we're going to allow that we are wrong about the linear correlation strength. But you don't have to worry about that. You're not going to be asked any questions about significance level. You just need to know how to look things up in this table. So first, if we're going to look up the critical value to compare the test statistic, then we need to actually calculate the test statistic, right? Okay, so notice here I've written test statistic. Remember, a statistic is a calculation, a calculated value, usually that comes from your sample, your actual data. So the test statistic is called R. And the critical value is comparison R. We have two types of R's, the one that comes from our data and the one that comes from the table. So the one in the table has to have n minus 2 degrees of freedom. So I'm going to need n, and does anybody know what n is yet? What does the symbol n stand for? Am I alone now? I think I'm alone now. Oh, sample size. Yes, Mark. Sample size. Can you guys still see my screen? Let me share that again. Okay, now you should see it again. Thank you. Okay. Yeah, so the sample size, right? Now, the sample size for paired data is you count the pairs. You count these pairs here. And so there's a total of 15 rows of data. One of the rows is headers, so that would mean n is 14. Another way you can get this is to use the count function. Now, I don't know how much I have to explain because of the videos I've assigned that walk you through the basics of Excel. So I kind of operate as if you've already learned what I've already assigned in videos. If you need me to go slow or repeat a step, please let me know. But by typing in count and then a parenthesis, or you can start by just typing in a few letters, find the one that has the right description. The first one here says counts the number of cells in a range that contains numbers. All right, so one looks right, so I'm going to double click that, and then you can either um, select the whole column if there's nothing else in that column, or if you'd like, you can go and select the data. Yeah, and I am going to, and actually, I think that was Mark that just asked, can I show how to look up the value? Yes. In fact, that's why I'm calculating n, because I need to know what the sample size is. And for this one is very easy. I can see it because it's in my Excel spreadsheet. It's going to be 14, but the count function is useful in some situations. So, yeah, so there it is, 14. Now, the table said it was how many degrees of freedom? N minus 2, right? So n minus 2 obviously is 12 here. You can also do the calculation in here. So 12 degrees of freedom. So I need to look up the R value with 12 degrees of freedom. So you can see it right there, 0.532. There we go. All right, so this is the one that I'm trying to beat. And this is the one that comes out of my data, my test statistic. All right, so does that make sense how to look up the R value in the table? Claire says yes. Mark, is that good? Can you show how you got the critical value one more time? Absolutely. All right, so first of all, this is the chart that we're referring to, the critical R values. And right here at the top of this column, it's just in two pieces because your degrees of freedom goes up to 19 and then starts again here and continues. So just depending on your sample size, you have different rows to look up. You see it now. Okay, good. Excellent. So yeah, whatever your sample size is, we had a sample size of 14 and we need to subtract 2 for the degrees of freedom. And so that's 0.32. Now, degrees of freedom is a concept that I don't think you're ready for. And I like doing linear correlation in the beginning. I think it's more interesting than some just kind of starting with definitions and all that. But I don't want you to worry about things like what is the degree of freedom, because we'll learn about that in a later lesson when you're more ready for that. And I don't want you to worry about the significance level. Just know how to look up the value in the table and how to calculate your test statistic so that you can compare the two. All right, so now I'm going to do the calculation for the test statistic. I'm going to show you two different things. For this problem, all they've asked me to do is determine if there's enough linear strength. And I'm assuming that's based just on the R value. However, when you're really doing linear correlation regression, you should also always look at the scatter plot. But just based on the R value, let's see what that linear strength is. Will you be in? Yeah, I'm going to be around till 9:45. So, and you can email me too. I've been trying to jump on those emails right away. But I don't know why you guys aren't receiving a response from me in your email. So I have to find out why. That's a couple things I got to figure out today. Because I answered all the questions yesterday and apparently they didn't come into your inbox. So I don't know if you can access them any other way. So I might have to start doing something different. Anyways, I digress. Where can I find your email? My email. It's on the syllabus. It's also on the faculty webpage. So let me quickly answer these questions and I'll get back to the problem. Go to syllabus and agenda. Right at the top is a link to my faculty webpage where you can see my address there. It's also in the syllabus, and I'll just tell you now what it is. But just so you know, if you're looking for how to contact me, faculty webpage and/or syllabus is always the way to look it up. But I'll type it into the chat room for anybody else that might be wondering. And I also put it in the welcome announcement. McDonald C at palmbeachstate.edu. All right, so my email address is my last name, McDonald, except for the D is not there, and then my first initial C. So McDonald C at palmbeachstate.edu. Okay, can I fix this problem? I have a little bit of ADD, don't I? But I want to make sure I'm getting to everybody. And if you want a more organized and quick, to the point lesson, that's why I recorded those videos for you. And if you're having trouble finding those videos, make sure you let me know so I can help you. All right, so here we go. We're going to start typing in. See, I want the linear correlation coefficient, so I'm going to start typing in correlation. And notice that this one pops up correl, which returns the correlation coefficient between two data sets. Excellent. Let's double click that. And then I'm going to select array 1, comma, array 2. An array is a selection of cells. So I want to feed it the x's, comma, the y's. And again, you can actually click the whole entire column as you're selecting the ranges, as long as there's no other stuff down there. It's only your data, or you can just select the individual cells. Okay, wow, that's a pretty good linear correlation coefficient, and it's definitely closer to 1 than this one is, than the critical value. So the critical value, all I had to do was meet or beat that goalpost. And I certainly beat it by a long shot. So I would say yes, there is linear correlation. Okay.
I have a question.
Yes. I get so excited when people have questions. Go ahead.
So the answer of 0.9 and the one with 0.5 are those two numbers is how I determine if it has the correlation or not?
Yes. This one is actually giving you a measurement by using the Excel just did this formula. Excel calculated this formula for this data and gave me back the strength of the linear correlation. That's the green value. And the critical value came from the table. And the critical one, it's called critical because that's the critical point that you have to meet or beat. Am I answering your question well? Or can you?
Yes, you are.
Yeah? Does it make sense for real?
Yeah, I understand now.
Okay, good, good. And there's another thing. We'll probably do it on a different question, though. I think we'll move on to the next question because we'll get more experience that way. I don't know if there was a question just now. Okay. Yeah. Okay, so we can move on from that because they're similar. There are more questions that kind of involve the same steps and extra steps for some of them. So this one again here, we have data that's paired and it says use your calculator. In our case, that's Excel. And R equals, okay, so I just need to calculate R again. Now, I'm going to share with you something that's kind of cool. If you have set up things a certain way, the way I've done it here, I've been making everything refer to cells. In fact, the whole column over here. So when I get a new set of data, if I've already set my spreadsheet up, I can copy and paste and just remove the data I have. So what I did right there, do that again. After you select it, right click and clear contents, right? And I can just do it on the entire rows here and then paste in the new data and it'll calculate everything. So if you don't want to start from scratch, you can set up your spreadsheet like this so that you can come back and use it again for similar problems. However, I have to change my critical value by hand because it's from a table. So notice this time we have a different degree of freedom. So our critical value will be different. So I'm going to go ahead and look that up. So for 10 degrees of freedom, it's 0.576. Yes, you will be able to use the chart on the test for sure. And so once again, we have very strong positive linear correlation according to this R correlation coefficient. Now, I've also recommended that not only do you calculate your R, but that you insert a scatter plot of your data. So I'll show that again, the steps I did. I select my data, go to Insert, and then Charts, the scatter plot. And so now I can see. I need to see that too because sometimes you'd be surprised. I mean, this almost looks like there's an underlying, that looks like there's a lurking variable possibly because there's another pattern in there somehow other than just a perfect. I mean, it may be that I'm just seeing things, but it looks like it's wavy, you know. So there's some other kind of pattern there. So if we were doing advanced statistics, we would be investigating that further. But we can see that it does look roughly linear and actually pretty tight. And we can right click these dots to add the linear regression line, the trend line. And if you scroll down, you can check the boxes to display the equation of the linear regression line and display the R squared value. Now, notice that they're using a capital R. That's okay. It means the same kind of R that we're talking about with the lowercase r. A lot of times the case matters in mathematical notation and even in statistics, but for this particular topic, R, lowercase r, is the same thing as uppercase R in the notation. Okay, so can you see that? So there's my equation. Here's my R squared value. Now R squared tells you a different measurement. It's kind of like a percentage, or you should read it as a percentage. And the way I would read this is I would say the values in Y, I see some variation in those values of Y, right? And that variation, the changes, the differences, can be explained by X the input values, or what we call the explanatory values. Explanatory. Also called the independent values. And the y values are called the response or the dependent. So R squared gives you a percentage of explanation. It's kind of a short. So what I mean is that your input value is explaining why. So I would say 97.55% of the variation in this y variable can be explained by X, and that's a high percentage. So that's one way of knowing if the model is decent. And we can take our test statistic from that value by doing the square root of R. Now be careful, because if this line is going up from left to right, so it should have a positive correlation coefficient. However, if it was trending downward and I take the square root of R squared, I'm not going to see the negative on there. I have to know to put that negative on before I enter the answer. So we have the answer here. It is positive 0.9. Let's see, what did they want us to round to? It doesn't say. Enter an integer or decimal number. Examples. Well, I'm going to try 0.988. Yes, I'll explain that again. R squared, you want me to show how I got R squared again? Okay, so that worked. To get R squared, I just added a trend line. Or since, let me make a little table here. So let's do, we're going to do R, and we're going to do R squared, and we're going to do one using Correl and one using the trend line. So there's two methods that I've been showing here. First of all, you can get R by using the Correl function. And you click on your X, comma, Y, right? And then from that, you can get R squared by literally taking the R value that you just found and raising it to the power of 2. Another way is using the trend line. So I'll show this part again. So I'm going to delete this chart and do it over. So the way I did this chart is I selected my data, then I go to Insert, Chart, Scatter. There's my scatter plot showing the nice linear trend. And then I'm going to right click and come down to where it says Add Trend Line. Click that, and you should get this box open up to format the trend line. You have to make sure it's on linear, come down and select Display Equation on Chart and Display R squared. So it's going to give me both the linear regression equation and the R squared value. So I can look over here and type it in 0.9755, 0.9755. And then to get R, I can take the square root of that. And also pay attention to the sign. If it looks downward, then I have to know that that would be negative. All right, so now we are almost to the point where we can answer question 15, which I'm going to skip to now. All right, I did this in a video, but I'm going to do it again here. Okay, let's read the whole problem first. And I'm going to quickly see if we had any other. You're welcome, Parsa. My pleasure. So we're going to go back and I'm going to read through this problem and do the whole solution. The following table shows retail sales in drugstores in billions of dollars in the US for years since 1995. Here's the data. Let S of t be the retail sales in billions of dollars in t years since 1995. A linear model for the data is f of t equals 9.44 t plus 84.182. Use the above scatter plot to decide whether the linear model fits the data well. Okay, I'm looking at it. I would say it definitely fits the data well. So according to that analysis, the function is a good model for the data. Then estimate the retail sales in the US in 2017. Okay, so they gave me the formula here, right? They've actually done everything for me. I can start from scratch and get this equation myself, but they've already given it to me. 9.44, let's see, so I'm going to say y, they used f of t, but I'm going to say it differently. Y hat equals, and can I just share my screen here? Y hat equals 9.44 t, well, I'll say x because we're used to using x, plus 84.182. All right, so let me explain. What is y hat? Y hat is estimated values that are on the line. So they're actually, you have dots from your data, so the blue dots, those are actual observations that were collected, observed. The trend line is trying to estimate everything. So if we zoom in a little bit, I can't zoom in there anymore, but if you can see, but like right here, the dot is a little bit below the line. So the line, the trend line, is overestimating the value compared with that observation. So this trend line just looks at all the dots and tries to make the smallest amount of squared error so that you get the best fit possible for those dots, and that gives you something to make predictions with or estimations with. Okay, so y hat is the estimated values, whereas we might just use regular y for the retail sales. I'm going to actually paste this in and show that notation. So the year is your x here. X years, x year. And that's years since 1995. X years since 1995. And then your retail sales are Y retail sales in billions of dollars. So X and Y, these are your observed a little bit more notation in here. Y is observed. Observed is Y, and estimated is Y hat. We put a hat on it. And so that would actually just look like a caret right above in the notation. Let me show you that. I might just have to make a brand new slide for this. Okay. Y versus Y hat. Okay, so Y observed for actual values collected from the population. And then we have Y hat. So Y hat, I have to do all this. This is why I usually just write Y hat, because to actually get a hat, you had to insert a formula. So Y hat, that's what it would look like, is the best predicted value or best estimate. All right, so now that we understand what this Y hat means, what it's saying is that you can estimate Y values by using this formula. So let's double read that question again, or triple read it. It says down here, estimate the retail sales in the US in 2017. So the retail sales, estimate retail sales, not sailboat sales, these kind of sales. Estimate retail sales in 2017. So what would X be? And then we're going to calculate the Y hat value using the linear regression equation. So if X is years since 1995, then in 2017, how many years would have passed? You can answer. How many years have passed? So you can, even if you want to, you can do it like this. 22. So using 22 years since 1995, what would the retail sales be estimated by the regression equation? Notice that we don't have in our data 22 years, so we don't even have an observation, but we can an estimation. All right, so now to do this, we're going to take that X value 22 and plug it right into our linear formula here. So I'm going to do an equal sign first. Remember, the equal sign turns any cell into a calculator, and I can type in 9.44, then times X. So I'm going to use the star key for times. X, I can either type in 22, or if I want to use this again for different values of X, I can make it so it just refers to whatever's contained in that cell, and then plus the y-intercept, 84.182. All right, so in billions of dollars, that would be my answer. in billions of dollars. So I'm going to round that off to 292 billion. 292 billion. Okay. And then it says use the model to predict the year. Use the model to predict the year in which sales will be 240 billion. All right, so now in this first question, we were asked to predict Y, the billions of dollars in retail sales. In this part of the question, we're asked to predict the year, the X value. We're predicting X now. Okay, well, I had something that was solved for Y. So if I want to go the other way around, I'm going to have to solve. Let me make this bigger. This way. So if I want to predict, this is going to predict Y values. Okay, but if I want to predict X, then I'm going to solve for X in that equation. So solving means that you get the variable alone on one side. And I'm just going to call it Y for this purpose. Y equals 9.44x plus 84.182. So to solve for x, first I'll subtract the 84.182 from both sides so that I get this result. Then I'm going to divide to undo the multiplication that's happening right here and get x by itself. I'm going to undo the multiplication by dividing. So now I'll have y minus 84.182 parentheses, and then that whole quantity is going to be divided by 9.44, and then x will be on its own. So now I have that if I do this calculation with a given y value, then I'll know what the predicted x is. So this would kind of be my x hat, if you will. So x hat, and I'll put it this way, since that's being predicted, I'll put the y first this time as the input. So they gave us in the problem, they said to use 240 billion. Right, so I'm going to put in 240 billion. 240 means 240 billion for this data. Then my solved equation here for x hat was quantity of the y value, which is 240, minus the 84.182 divided by slope 9.44. And so now that's the number of years after 1995. So we'll want to add that. They asked us in what year. In what year would the retail sales reach 240 billion? So it would be 16 and a half years after 1995. So I can add 1995 plus that. And so we would be in the year 2011. Okay, so the two answers, did I already answer that one? I think I did. So let's just put in 2011 for the second part of the question. Okay. All right. So now I'll just wait on you guys to ask me to clarify anything or repeat any steps or anything like that. Okay, we still have Claire, Parsa, Ryan, Sine, Thomas, and Vanessa. Claire says now it makes sense. Very good. Parsa, Ryan, Sine. I'm good. Good, Ryan. Okay. So if you think of any questions, you can pop them in there, but I'll just try to repeat some of the things that I noticed some students just were not aware of, even though I've talked about them. I guess I'll talk about them again just to make sure, because there's resources in here that I don't know if you're seeing them, just not helping that much, or if you don't even know they're there. So you can let me know if you struggled with that assignment. I'm going to show you a few things, and then you can tell me if you knew they were there already and that they just didn't help when you tried to use them. There's the textbook pages, which you can read through. And reading the textbook is not a replacement for a lesson. However, when you read the textbook, you will get important information from it, like understanding the notation, vocabulary. You'll get to see examples. And so you don't have to read the book first. I've recommended a workflow to start with watching some videos, class participation videos, then go to the textbook, then maybe watch the chapter video by the authors. So the second thing I showed you earlier is the vocabulary and formulas, which has the R table on the very last page. Another resource is the Lesson 1 videos link, which has the YouTube playlist where I've collected all the videos that I like, that I think are good and helpful and are related to this course. And the Chapter 12 authors lesson. And these are the 3 new ones where I'll go through a full lesson on linear regression and correlation here to try to supplement this chapter 1 that I guess just didn't quite do the trick. Either that or people didn't see it. And that's what I'm trying to find out. Did we actually see it and it didn't help, or did we just not know it was there? And then there's the using Excel to perform regression. That's kind of part 2 of the first lesson and what I just showed you. And then we have problem 15 that I did with a student in Collaborate yesterday. It's Q&A style. And then there's more. There's how to do scatter plots and correlation with Excel. That's been there. Did we know it was there and it just didn't help? Or maybe it's just a matter of trying to get used to where things are in the course. There's also solution problems for problems that would show up in your assignments down there too. Okay. Then we have class participation. So I've assigned videos, including the chapter 12 one. So I'm assuming anybody who did their class participation would have seen that video, and that's why I'm thinking maybe it wasn't as helpful as I assumed it would be. Then we have, of course, the assignments at the end. And then there are the videos actually attached to the individual questions. All right, so just reminders for you guys. And is there anything else I can do for you right now? Would you like to see a certain type of problem again, or another type of problem? Thank you. Have a great day. Oh, thank you, Claire. You have a great day too. What can I do for you? Let me do something for you. Oh, you're welcome, Pardon. Thank you. And you stay safe too. We're going to get through this. We'll have stories to tell our grandkids. For the participation, is it due the day of class at 8 a.m.? Yes, it's due the next day before class. So for today, let me remind you that there is when you go to syllabus and agenda in Blackboard, the agenda shows the pacing of when things are due. So for today is Wednesday the 15th. Oh, guys, taxes are due today, by the way. If you didn't file your taxes yet, make sure you get done today. Yeah, the agenda lays it all out. And so for today, lesson 2, sampling methods, which after doing lesson 1, you're going to feel like you're in kindergarten, probably comparatively, doing sampling methods. It's a lot of definitions and, you know, no heavy. For some reason, the phrase heavy plant just came to my mind. Does anybody know what the phrase heavy plant means? Just curious. I'll tell you what it is if you don't. LOL, no. Heavy plant. It sounds like it could be something naughty, like a plant. But it just means large machinery. I don't know why that's making me laugh. I think I'm just tired. It's too early in the morning for me. I'm not a morning person. Heavy plant. It's like when you see a construction site and you see the bulldozers and the cranes and all that, that's what would be referred to as heavy plant in the industry. And I only know that because of a storybook that I have for my son. I don't know who gave it to him, but the whole book is describing all the things that you would find on a construction site. So now I know a lot about construction sites, I have to say. You learn a lot by having kids. So I'm just kind of rambling and killing time. Is there anything? So are you guys just hanging out because you're working on your assignments and you may want to ask questions? That's fine. I'm just curious if you're hanging out for any, if you're hoping I'll start doing some kind of performance or more questions or anything. I don't know. I just want to be helpful and useful. Textbook is there. The only video that did not work for me was one in the lesson 1 guided learning assignment. I followed the directions, but my answer still came out wrong. Oh boy. However, you covered that issue today. Also, I'm watching all the videos for class participation. I just can't see the results, so it's concerning, but you also covered that. Yeah. It makes you nervous because you're not sure if I received your work kind of thing, Sine. Textbook is there. Yeah. Yeah, I'll try to get that updated. To tell you the truth, it's a bit of a pain to do it. So I kind of wanted to do it at the end of the week, one time for everybody for the whole week. And that's why I'm avoiding doing it, because it's not easy to figure out what everybody's, at least it hasn't been easy yet. Maybe I'll find a more efficient way of doing it, but I'll get it up there as soon as I can, but I don't know. I think it's not going to happen until tomorrow. No particular reason. Now that you're finished with your explanation, have a great rest of your day. You too, Ryan. Thank you. Sine, can we talk a little bit more about what you said? The only video that did not work for me was in the lesson 1 guided learning assignment. So it was actually a link within the OHM assignment. Have a great day, Thomas. Bye-bye. So it was, I followed the directions, but my answer still came out wrong. Did you send me that question? Did you click message my instructor when that happened so I can track it? And Sine, if you want to just actually talk to me, you can do that. You can enable your microphone. No, I didn't. Do you remember which one it was by any chance? Which question number? Maybe
So it was the first question that you had to like manually do, I'm gonna say.
You mean like a calculation instead of a multiple choice?
Yes.
Okay. I'm gonna see if I can find it real quick. So maybe this one?
No.
This one.
Yes.
All right.
I also don't have the calculator, so I tried doing it in Excel.
Annual high temperatures in a certain location have been tracked for several years.
Okay. So in this one, he only goes over the computer. I meant to say the calculator. And did you happen to see this one right here?
No.
This video
I saw the one where he like copied and pasted the graph into Excel, and then he basically used the equal, then the Corel, and then he
Oh,
put
he
in,
did.
yeah, he used like the B and the C, and then clicked equal, and basically went on from there.
regression with Excel.
But it wasn't this one.
No.
And what we want to do with linear regression is take a set of data that's paired. So we'll have a
All right, so this one may have been better. Not that it matters at this point because I've already shown you, but you may want to refer to this, I don't know, later. And for future reference, you might find that some of the links in here will supplement because that's why they're there, is, as recommendations to help out with certain problems. And so I think I'm learning a lot about how to make these more obvious, where to find things.
Yeah, because we also get the notifications that you sent, I want to say.
Mm-hmm.
Yes.
Okay. Well, thank you for sharing that. And is there anything else I can do for you?
No, that's all. I also think it's very reassuring for like a teacher that's going over something new with a good amount of students. Yeah, like
It's reassuring.
yeah, like you take time to like answer questions and
Oh,
you take time to send emails back and send replies back. So
well, thank
thank
you
you for
for
that.
sharing that. I really want to be as much of a help as I can. So it's good to hear that that's how I'm coming across.
You're welcome. Thank you.
You're welcome. Have a good day.
You too.